So this we were discussing about the momentum and collisions, the assignment question 80. Question 19, question 18 is already there. So in 1920, Patrick's investigated the interaction of the alpha particles with different atomic nuclei. You can see the path there. The alpha particle rebound off the nitrogen. And this is the direction in which the alpha particle rebound. And this is the direction in which the nitrogen. But the nitrogen in the beginning, as you can see, is stationary nitrogen. So nitrogen was not moving. In the beginning, it was stationary. So if you represent, like say this is representing a nitrogen and this was alpha. Alpha is because two protons and two neutrons, it's lighter, it recoil, and the nitrogen move in this direction. We're making an angle 10.9 with the x-axis. This was making 30.0 or 30 degrees with x-axis. So the mass is there. Mass is 4u. If you're taking a ratio, in that case, if you don't convert the mass into kilogram, that's fine. Like if you use your answer in u also, that is also fine. The fine because that will cancel out each other. U will cancel with u, so it won't make much difference. If you want to convert, remember one atomic mass unit. One atomic mass unit is a mass of one proton or neutron, which is 1.67 into 10 power minus 27 kg. That's the constant. Now, first what we do, we resolve the momentum into its component. The alpha particle is there. So what is the mass of alpha particle? The mass of alpha particle is 4u. And what speed it was moving? In the beginning, the initial speed is 1. So this will be the mass times the speed, which is 1.2 into 10, 1.20 or 1.2 into 10 to the power 7. That is a momentum of the alpha particle, initial. What about the initial momentum of the nitrogen? As I mentioned, it was stationary, it was not moving. So the initial momentum was 0. When they collide, the alpha particle move with a speed of 6.93 exponent 6. So the mass won't change as it is for you. This speed is how much? That is 3.63 or 3.93 exponent 6. So this will be the momentum after. But this momentum will have the two components. The one with the final momentum will have two components, the one with an angle and the direction, as you can see here. So this will be with, because it is with an angle, so this will be cosine. Like I can write here 4u into 6.93 into 10 to the power 6 cosine 30. And this will be the vertical component, that is equals to 4u times 6.93 into 10 to the power 6 sine 30, the vertical component. And remember, this is in a direction is this one for the final. But for nitrogen, it will also have the two components. Initially stationary, final will have two components. The speed, we have to show that the speed, so speed of the mass of a nitrogen is 14u. So this is 14u. And so this will be 14u. And the speed, we want to find its speed. Example, we say the speed is v. The speed at which this nitrogen move, that is v. So this will have two components with an angle, that will be 14u cosine 10.9, and opposite will be 14u sine 10.9. Okay. So, and it's important that you draw the arrows to show the direction as well. Because when we use a conservation of the momentum, as we know, the momentum before is equals to momentum after. But because it's a two-dimension, so when we take the conservation of momentum, we'll take x direction separate and we'll take y direction separate. So if we take the conservation of the momentum in x direction, So first, if I say right, because this was momentum before should be equals to momentum after in x direction. So this was 4u times 1.2 into 10 to the power 7 plus 0 because it was not moving equals to, look, this has changed the direction. So like it will be for you, the alpha particle, because momentum in x direction for alpha and nitrogen before and after must be equal. So this will be for you into 6.93 into 10 to the power 6 cosine 30. But what I should take? I should take a negative sign. Why I should take a negative sign? Because this is in opposite direction. Like it has the horizontal component before was towards right, but now it is toward left. So I have to take a negative sign. Plus the momentum of nitrogen. I'm because of space, I'm writing it here. So it will be 14u, uh, 14uv. Actually, v will also be there, because v is the speed at which it is moving, and this is a mass and this is a v component, so it will be 14uv. So this will be 14u, then v, the speed, and then cosine 10.9. Now u is common factor in all, so this u will cancel out. Then we can just simplify, as v is one of the unknown. So we can use this equation. So we don't have to use a y dimension. We just use the x dimension here. And as you can see, we have only one unknown is there in this equation, which is v. So we'll make a subject v and we find the speed at which this nitrogen will move. And remember that the answer, like when you simplify, your answer will be 5.2 exponent 6 meter per second. The remaining part is just a subject, like making a subject v and solving the equation for v. So here we don't have to do y direction. Why? Because when we did the like momentum, conservation of momentum in x direction, we found that the unknown is only in the equation. We have only one unknown, so we can solve it for that. Is it clear? Okay. The next guy, so you have to just make a subject for V and then work out. So after getting the speed, the next is determine whether the interaction is elastic. So to know elastic or inelastic collision, what you have to do, you have to check the momentum before equals to momentum after. But because energy is a scalar quantity, so you don't bother about what direction it has moved before and after. You don't consider, like, even it rebound, even it change the direction, even it does not change the direction, that does not make difference. So whenever you want to check that it has an elastic or inelastic collision, so what formula you will use? You'll use a formula that kinetic energy, because to, like, half mv square, half m1 u1 square plus half m2 u2 square, like the speeds and the kinetic energy of the two particles before must be equals to the sum of the kinetic energy of the two particles after interaction. That's it. So what you have to do, you just have to substitute, even like it will be half m1 is a first mass, which is 4u, and the speed at which it was moving in the beginning of question, they mentioned it was 1.2 into 10 to the power 7, and then it will be squared, plus half mass of a nitrogen was 14u, but it was not moving, so it will be 0 square. So mean this factor will be 0. So you will get the energy in this part, and then compare with, because we have, for a conservation of momentum, collisions to be elastic, the total energy before must be equals to total energy after. So it will be half. M is a mass of alpha particle, which is 4u, and what speed it moved. Even though if you see in the question that alpha particle has changed the direction, But because energy is a scalar quantity, so change in direction, change in component does not matter at all. So we don't use any component here. Directly we substitute the total, which is 6.93 into 10 to the power 6 plus half. The mass of the nitrogen was 14 U and the speed at which it was moving. The speed at which it was moving, that is given in the previous part. So that is 5.24 into 10 to the power 6 square. So when you substitute, if the two values are equal, you will say energy is conserved. If the two values are not equal, you will say energy, if energy is conserved, it means the collision will be elastic. If it is not conserved, then the collision will be inelastic. So it totally based on your calculation, half mv square. So if we get the same answer, expected answer to be collision to be elastic, but according to the question, you have to solve and work out. Next is question 20. A student read the following extract from the textbook. In an inelastic collision, the objects of equal mass, where one is initially stationary and the object move off at 90 to each other after collision. So student read that if the collision is elastic collision, when two objects are having the same mass and they collide, if one of them is stationary, then as a result of the collision, the two objects will move at a 90-degree to each other. That is what student read. The student investigated this by using as two identical steel balls, each of mass 66 grams. The diagram illustrates the collision between the balls. In one experiment, U1 was 0.72 and the angle was 29. For such collision, it can be shown if the balls are separated at a 90, then V1 is 0.69, 0.63, phi is 61, and V2 is 0.35. Show that these values satisfy the condition for conservation of momentum in initial direction of a ball. Means like this, where initial direction of a ball means momentum is conserved in x direction. So we have the values here. And if the balls are separated by 90, so, and the value of a theta is 29, this is 61. So theta is 29, phi is 61, 0.63 and 0.35. So theta dimension is 29. This will be 61. V1 was 0.65, 63 and 0.35. So we have to show that the momentum is conserved in x direction. Twenty-nine was there and 61, and this was 0.63, and this was 0.35. And the ball was moving. Initial speed of the ball was 0.72. So 0.72. And each ball has a mass of 66 grams. You can convert into kilogram as well as the SI unit. So it will be 0.066 kg. So this will have the two component. Like I will use the term M here for all of them. Reason why I'm using a term M, because they mentioned they all have the same masses. So if I need to get the final value, I'll just substitute. Otherwise, I'll use the term M. So this will have two components with an angle. So this will be The mass is m and the speed is 0.35. And what angle? The angle is there because, sorry, this is V2 is 35. Yeah, V2 is 35. Okay. And phi was 61. So what I will take, this will be cosine 61, and there will be a component against the angle. This will be m times 0.35. It will be sine 61. And for this one, this component will be m times 0.63 times cosine 29. And this will be m times 0.63 times sine 29. And this will be negative. Why? Because if one is, like, it's up to you. Any one of them you can take positive, the other one will be negative. And the initial momentum, so if we have, the question is, we have to show the momentum is conserved in x direction. So how to show that momentum is conserved in x direction? Like direction of a ball one, which is x direction. So momentum before, so it will be m into 0.72 plus this was not moving, so the momentum is 0. Then what components we'll take? We'll only take in x direction, so we will take this as m 0.35 cosine 61 plus m times 0.63 and cosine 29. And then m will cancel with m. As you can see, m is common. That's why I did not substitute the value. So m will cancel. So what we are left with? We are left with 0.72 here. And we are left with 0.35 cosine 61 plus we are left with 0.63 cosine 29. So we'll find the value of this one, this side. If it is, both sides are like, the left hand side is 0.72, if the right hand side is also 0.72, what it shows? It shows that the momentum is conserved. So approximately it will come out same, like the left hand side and the right hand side momentum should be same. The next part, show that these values satisfy the condition of elastic collision. So the same thing for elastic collision, what we do, we write the kinetic energy before, but when we are writing a kinetic energy before, you don't bother about their directions. You just substitute the magnitude of the speeds. So half mv square, half m1 v1 square. So don't you, because it's a square, is equals to half m2 v2 square. This is u1 and u2. So the total sum of kinetic energy before must be equals to sum of kinetic energy after. So if it satisfy this condition, it means the collision is elastic. So irrespective of the angle, because you don't have to substitute the angle, you just need the magnitudes, and you have the magnitude of all of them. You have v1, you have v2, even you have u1 as well. You have u1, this is given, this u1 is given, and this ball was stationary, so u2 was 0. So the sum should be equal. The photograph shows the student's actual result of this experiment. The position of the positions of the colliding balls at a successive time intervals have been overlaid on a single image. State the additional information that student needs in order to determine the speed of the balls. So, like, this is like a photographs are taken and then they overlap and make a single image. So what additional quantity student need to work out the speed? So speed is distance over time. So because like if you want to work out the speed is distance over time. So I need the distance here and I need the time. So how to know the distance? So we'll know the scale of this image, because if we know the scale, like example, this much length equals to 1 centimeter. So we can identify what is the distance covered by the ball. And we also know the time interval of between the successive images, like between the two images, what or how many frames are there every second. So using a frame per second, we can work out the time, and using the scale of the image, we can work out the distance, and distance divided by time, we will get the speed of the object from this image. Because the question is how we can work out the speed of the object, determine the speed of the balls by using the image. Then student looked at the photographs and he noticed that the angle between the path of the two balls after collision was not 90. He modeled the collision on a computer. He used the same initial values of a ball 1 and the theta. The computer calculated the total kinetic energy after collision for a range of phi. Measure phi from the photograph and use a graph. Suggests why the angle between the paths is not 90. Measure the phi from photograph. What is phi here? Phi is the angle. This angle is a phi. Phi is the angle of the second ball. Okay. So you have to measure it from the photograph. How to measure from photograph? So you have to draw a line first, because phi is the angle. If you see, the phi is the angle between the initial direction and the direction in which it moves. So what is the initial direction here? If you use a scale, a ruler, and we draw this line, which shows the initial direction of this ball. Okay. And this is the direction in which the ball to have moved. And this will represent the phi. So what you have to do, you have to measure this using a protractor. You have to measure this. The value of a phi, it will be around 44 or 45 is there. So you'll measure the value of a phi. And from the measured value of the phi, like example 42, 44 is there, you'll find the kinetic energy. So as you can see, the kinetic energy before and after is not same. Like before is different. What is the kinetic energy before? The kinetic energy before, as the ball was one was moving, which was having a mass of 0.66, and it was moving at a speed of 0.72. So 0.66 times 0.72, that will give you the initial kinetic energy. So sorry, half mv square, because kinetic energy, not the momentum. So half 0.66 into 0.72 square. When you sum this, you will get a 0.017 joules. So this is a before. And when the angle of a phi is 44 or 46 according to the figure, we get the total energy after collision. We are getting about 0.01514. So it means before was 0.017 and after 0.014. It means the energy is not conserved. Like before and after is not same. So we have what suggests why the angle between the paths is not 90. So why the angle between the paths are not 90? Because the collision might be inelastic collision. Because according to the original text, when there's an elastic collision, then the angle will be 90. But if there's an inelastic collision, the angle will not be 90. So, and you can show this by the value, like you will take the value of a phi, work out the total kinetic energy. You will say the total kinetic energy before and after is not same, which shows that the collision is inelastic. And in case of inelastic collision, the angle between the two objects which are colliding will not be 90. It will be 90, if the collision was elastic. But if it's not 90, then because this statement, the text from the book state that in elastic collision, the angle will be 90 when one object stationary collide with a moving object, like a moving object collide with a stationary object. But if the collision is inelastic, this angle won't be 90. Is it clear? Question 20 about the momentum.